Hello, so we're back to the land of hypothesis testing. This week we'll be going over ANOVA. So, what is ANOVA? But before that, let's do a quick refresher on independent samples t test. So, remember, independent samples t test, we covered situations where we have two groups and we're comparing means across the two groups. So, for example, a clinical psychologist may want to evaluate a therapy technique by comparing depression scores of patients in two different therapy programs. So here we have two groups, therapy program A and also therapy program B, and we're comparing the means across the two groups. So the question now is, what if we have three groups? What if we have four different therapy programs? Can we use independent samples t-tests? The answer is no, we cannot. So then we can use something called ANOVA. ANOVA allows us compare group means across two or more groups. So when we have two or more groups, analysis of variance is what we want to do. So ANOVA analyzes differences in group means to determine if at least one group mean is significantly different from other group means. So what ANOVA is doing is, assuming you have three groups, ANOVA is just checking to see if at least one of the groups is significantly different from the other two groups. So note, an ANOVA does not tell you which group is different. It just tells you that at least one group is significantly different from the other groups. So an ANOVA test is significant if at least one group mean is significantly different from other groups. So just the logic continues here. ANOVA is just when we have two or more levels of the independent variable, which is our qualitative variables, and we have one dependent variable. So we have different groups and we have one quantitative variable. So I have three examples here. So assuming we're comparing the number of hours students study each week by their class standing, freshman, sophomore, junior, senior. Or if we're studying the effect of tea on weight loss across three groups. So here we have green tea group, black tea group, and no tea group. Or are there differences in the height of U of A college athletes by the sports they play? So here, height is our quantitative variable, and the type of sports they play, football, basketball, baseball, soccer, track and field, those are our groups, which are the qualitative variable. Okay, so just for you to see what it looks like in picture. So the first guy here, the number of hours is what we're measuring across four different groups. So freshman, sophomore, junior, senior. And here we're measuring weight loss for the no tea group, the green tea group, and the black tea group. So here we have more than two groups. That's why we're going this route. So that's why we're using ANOVA, because we have more than two groups. Okay. So just you can pause this video and just read these two quick notes. So here, if we want to know whether the mean blood pressure for individuals receiving medication A is different from individuals receiving medication B, we only have two groups here and we're comparing the mean blood pressure. So for the first bullet point, the independent t-test is what we want to use, right? But for the second bullet point, what if there are three medications under investigation, medications A, B, C? Do you think the independent samples t-test will work? The answer is no. We would use ANOVA for the second bullet point. So the first one will be independent samples t-test, and the second guy would be ANOVA because we have three groups and we're comparing the blood pressure across three groups. So ANOVA would work for the second one. Okay. And this is just more examples on ANOVA. You have three different population groups in this scenario, and you take the different sample means and you're trying to see if the sample means are similar or are different. So the purpose of ANOVA is to test to see if there is a difference somewhere. Remember we said we're trying to see if there's at least one group difference. If there's one group difference, then there is a significant difference, right? So hence, the null hypothesis for ANOVA is that all population group means are equal. So all the group means are the same, right? Then for the alternative hypothesis, says at least one of the population group means differs. Note this is saying at least one of them is different. If one of them is different, then the test would be significant. Okay? So how do you write this non-alternative hypothesis in notation? So the first guy here, you've seen something like this before. It would be that all the group means are the same, right? So mu1 is equal to mu2 is equal to mu3 all the way to k. So k would be the number of groups that you have. We'll get to these details next soon. Then the alternative hypothesis, this guy here is saying that every group mean is different. But this is not what the alternative hypothesis should be. The alternative hypothesis is that at least one group mean differs. So this guy here is wrong. So the way to write the alternative hypothesis is to say that at least one group mean differs. So at least one of the group means differ from others. So this would be the correct way to write your alternative hypothesis. Okay? Okay, let's continue. Let me delete this guy. Here you go. Okay. So independent t-test, we computed the test statistics using the difference between the group means, and we divided that by the standard error of the differences. When we have more than two groups, it becomes computationally difficult to take the differences. So the only solution here would be to use a variance to define and measure the size of the differences among the sample means. So we'll be using variance. So you see examples on how to do that. So let me give you this quick example. Assuming we have three different groups, M1, M2, and M3, and we're comparing the means of these three groups. Let's look at set 1. You can see for set 1 we have M1 equal to 30, M2 is equal to 40, M3 is equal to 50. The group means look different. 30 is different from 40, 40 is different from 50. Okay, hold that thought for a second. So look at set 2. We also have three groups and the numbers are 25, 30, and 35. And if you look at set 3, we have three groups as well, but all the three sets have equal means. Now let's compute the variance of each set. So the variance between these three values for the first set is 100. The variance of the three values for the second set is 25. But of course, the third guy, they have the same scores, so the variance is 0. There's no variability among them. So you can see for set 3, we would say that there are no differences because the variance is 0. But set 1 has the largest variance because the numbers are farther apart from each other compared to set 2, which variance is 25. And that's what I put here. So as seen above, set 1 appears to have larger differences among the sample means, 30, 40, and 50. Set 1 also has the largest variance among the three sets, which is obvious because the numbers are farther apart. Set 2 produces a variance of 25. Among all three sets, it has the second largest differences in means, which is true. And the sample means of set 3 are all the same, so we have 28 for all of them, and the variance is 0. This makes sense because there are no variability among the sample means. So this is just setting you to start thinking with variances. That's what we're going to use to calculate, to find our mean differences for ANOVA. Okay. So what ANOVA does is to compare, so hence we will rely on variance to measure the sample mean differences when there are two or more samples. So ANOVA, what it does here is to use the F statistics. So like for T, we use the T statistics. In ANOVA, we'll be using something called the F statistics or F ratio. So F ratio takes the variance between the groups. So it compares the variance between the groups that you have and the variance within the group. I'll get to these details on my next slide. And ANOVA follows a distribution which is called the F distribution. So that detail will come in the next video. So we'll continue in the next video. Thank you.